Okay, this video is going to deal with what we did in week 17, day 1, and this is just another step in the idea of indefinite loops. So just a brief review. Definite loop executes the loop a predetermined number of times. So the programmer decides beforehand this is going to run 5 times, 12 times, 64 times, whatever. It's predetermined. It's also called a counter-controlled loop, and we use it for while, for, and do-while loops. All can be definite loops. Now, an indefinite loop is one in which the programmer sets it up so that we don't know how many times it's going to be run. And there's two main ways that this can be done. One is you make it, you see they're called event-controlled loops. So one way to do that is to have the loop control variable store the user response to continue or to not continue. And so if we were to look at this right here, what you would see is that this is just a template of an indefinite while loop. So you have a variable called the loop control variable that is, we're going to name it response. Now before we named it count, you want to name it something that makes sense of what it does. Now count actually is counting, it's incrementing by 1 typically to show how many times a loop is being executed. In this case, we're not counting each time it goes to the loop. What we're doing is we're going to be asking the user for a response on if they want to continue or not. So we're going to name this variable in a way that fits what it's going to do. So we don't want to name an indefinite loop control variable count, because that doesn't make sense. So the value of the loop control variable is determined by the user. And so in this, what happens, there could be other code up here. This is, just a template. And so you set it equal to some number. In this case, we're going to set it to 1. And so while response is equal to 1, then we're going to jump into the loop. And so do whatever the statements are that need to be repeated in this loop. And then we have a system.out.println statement that says enter 1 to continue or another number to stop. So the user then sees that question, and then they type in, let's say they type a 1. So now the response stays as 1. And so this line, of course, has to read the input, and then store it into the variable response. So here's the end of the loop, and so we return back to while. And of course, response is still 1 because that's what the typer or the user did, is they put in a 1 because they wanted to continue again. And so it goes into the loop, it comes through all this stuff, and then it asks them again. So maybe they type a 1 again. So we don't know when they're going to say to stop. And so this keeps going through here until eventually they actually type another number. Well, let's just say they type a 2. So 2 gets stored into response right in this line, and then this goes back to the while loop, and now while response is equal to 1. Well, it's no longer equal to 1, so the loop stops, kick out of the loop, and go and continue the program. So this is a situation where we do not know when the user is going to say no or they need to stop. So it's an indefinite loop. Okay, the other method, or another method that can be used for an indefinite loop, is the loop control is controlled by the value of one or more accumulating variables. And so what we're going to do is we're going to simulate this. We're going to show how the value of one or more accumulating variables will actually determine when the program is going to stop, or when the loop is going to stop. And so what we want to do now is we want to play a dice game. And so the dice game is we want to write it. We're going to be writing a program for 2 players, And the players are going to trade off rolling the dice, and then they enter their score. And then the game stops, though, after a set of rolls. After a set of rolls, one of the players has 40 or more points. So they trade off rolling the dice. They keep track of their running score. When one of the players has reached 40 after one set, so each player or both players roll the same number of times. One of the players, once one or both of them have 40, then you stop and you see who wins the game. So if you're watching this by video, of course, then we are going to just show that game here, and so this is how it would work. So let's say that you have Sally and Jim are going to play, and so Sally rolls an 8, and so she has 8 so far, and then Jim rolls a 10, and so now they've both rolled 1, so now this is one set of rolls, and so the score right now, Jim is ahead of Sally. And then Sally rolls again, and she rolls a 10, and Jim rolls a 5. Okay, so so Sally, now you take 8 plus 10, and so she has 18. Jim has 15, and so after 2 sets of rolls, now Sally's now in the lead. And then Sally rolls a 12, and Jim rolls a 7, and so now Sally has 30 and Jim has 22. So that's the score so far. Now you have another roll, and Sally rolls a 6 and Jim rolls a 10, and so 36 to 32. Alright, then the next roll, Sally rolls a 6, and Jim rolls a 7. Alright, so Sally now has 42 and Jim has 39. Okay, at this point now one of the players has 40 or more, and so now the game is over. Alright, and so what we want to do is write a program that simulates this game. So two people could use the program to play roll the dice, and once somebody gets to 40, in other words, you don't have to calculate everything, but the computer does. Once somebody gets, or both of you get to 40, then the program will stop. So before we do that, what we want to do is we want to make a list of the variables that we're going to need by stating the purpose of each variable. For instance, you say, well, I need a variable to store the number of cookies Sally ate, or I need a variable that stores the number of days till Christmas, something like that. So if you want to try that, then pause the video, and then I'll show you the answer after that. So the variables that we need is we need a variable to store the role for each player. Now, what I told students in class is you should be able to look at your paper, because everybody was writing this on paper. You should be able to look at your paper and see what the variables are. Remember, variables store values, and so, well, you have Sally's role, and so here's Sally's role, so it's going to store each of her roles. Now, what it does is it stores just one role at a time, and then Jim we have to have a variable that stores his role, and then we have a variable that stores Sally's running total and a variable that stores Jim's running total. Alright, so those are the 4 variables that we need. That's all we need, is those 4 variables. Okay, the other thing that we want to discuss before we actually do this, write the program, is which variables are counting and which variables are accumulating. Well, remember, the variables, counting variables, are ones that go by 1. So when you count something, you go 1, 2, 3, 4. You're always adding 1. Do any of these variables increase by 1 each time? And the answer, of course, is no. So none of these are counting variables. Now the other question is accumulating. Well, accumulating is when you keep track of a running total. Okay, so you keep accumulating more, and so it keeps track of a running total. So when you're done with the program, you have the final total. Well, this is not doing it. This is not increasing each time. This variable is not increasing each time, but this one is. Sally's. Keeps track of a running total. She keeps increasing each roll each time through the loop, so to speak. And Jen the same thing. So these are the two that are considered accumulating variables. Okay, so the other question we want to ask is, this being an indefinite loop, are we going to use a while loop or a for loop? And the answer to that question is we're going to use a while loop, because for loops are used only for definite loops, only when we have a predetermined amount or number of times that the loop is supposed to be executed. So we're going to use an indefinite loop. What event's going to cause the loop to stop? Well, what's going to cause the loop to stop is when one of the players or both of the players reaches 40 or more, and so something like this. So we don't want the loop to stop when they're both less than 40. Here they're both less than 40, both less than 40. But here it stops because one of them, now it could have been both of them, because two players could enter or have over 40 at the end of a set of rolls. In this case, just one. So then this would stop it. That event is going to be that one or both of the players reaches 40 or more. In what part of the code will the answer to the previous question be reflected? So the answer to this is going to be reflected in the Boolean expression of the while statement. And so if we look at this template here, which I lost it, okay. So in here, only it's not going to be response equals 1. You're going to have to make a different Boolean expression. But if you look at this, it's got to be reflected in this Boolean expression of the while statement. And then that's basically it. So what you need to do now is to write the code that will simulate this game. I would suggest you write the code for one term and then figure out, okay, what's going to add, what's going to needs to be repeated. The other thing that we need to remember is we need to finish on your program. What you should say at the end is you should say something like player 1 wins, and then go like 42 to 39. So you want to have use code that will determine who wins the game. So here we've got all this happening. This is going to be taken care of in your loop. Once the loop is done, then you want to write code that determines who wins, and then you want the program to display on the screen that player 1 or something, whoever wins, and what the score was. Or remember, it could be a tie. Alright, go ahead and do that, and then I'll show a solution to that. Or actually, the solution to that will be posted on Canvas, so you can see what an example of a program that makes this work. And that's it for day 1 of week 17.